Hello teacher, this is Amber So from LE18 and I'm here to present my EMAth video. This is the article that I have chosen. And this is what I inputted into my Excel sheet. So for part 1, the source I've chosen is Sleep Duration, Quality of Life and Depression in Adolescents, a school-based survey written and surveyed by PubMed. The claim states the mean of the population they use is 855 for teens aged 14 to 19 and their average sleep duration is 7.23 hours. Moving on to part 2, the hypothesis I made is that teenagers do not get the 7.23 hours of sleep that the source claimed they do. My null hypothesis, which means there is no difference between the statistical value of my data compared to the data of the source, is that teenagers do get the average sleep of 7.23 hours. My alternative two-tailed hypothesis, meaning that there's a difference between the data compared to the source, is that teenagers do not get the average sleep of 7.23 hours. The reasoning for the alternative claim is to test my sample's average sleep duration with the sources without assuming beforehand whether it will be higher or lesser, so a two-tailed test is more objective and unbiased. For part 3 data collection, I use Google Form to collect data. For my first question, I made sure that they are ages between 14 to 19 by only putting those numbers as options. For my second question, it is a free response question and I asked them to answer in terms of hours. I then used the responses of the first 30 people that responded and input it in the datasheet of my Excel. My sample would be suitable for testing the claim as I use the same age group respondents as the source so that it is directly comparable and accurately reflects the number of hours teenagers sleep in my sample. Moving on to part 4, my sample size, which is the number of respondents I got, was 30, and my sample mean average sleep duration of the respondents was 5.77 hours, and from there, I calculated the standard deviation, which tells me how much the values in the data set differ from the average, is 1.44397. The source population mean sleep duration was 7.23 hours, and the source did not provide standard deviation. The degree of freedom, which represents the number of values in the sample that can vary independently, is 30 minus 1, which is 29, which is data points free to vary. The given significance level alpha value is given as 0.05, and it tells me the cutoff point for deciding if my p-value is small enough to consider my test results statistically significant. Since the population standard deviation is now given, I used t-test and got negative 5.53082 and used the formula to calculate for the value of p and got 0.0000582, which measures how strong my evidence is against a null hypothesis. Since my p-value is less than the significance value, it shows my result is statistically significant. Error of margin tells me how much my sample estimate may differ from the true population value because I'm only using a portion of the sample and not the whole population. The calculated value is 0.53919. The confidence interval, which is a range of values that I think is the true population mean is likely to fall in based on my sample, tells me how precise my estimate is and how big small my error of margin is.